What you... And my team coming here to make fun of me. Let's see what we got. Let's see what we got. I announced the things. I pinged everybody.
Yeah, you announced it.
Everybody's pinged. I'll just have no people show up. Yesterday was a nightmare.
What's your bit rate for your stream?
8,200 is Ethernet.
Oh, okay. I'd be like, if you're doing that on like guest internet.
Actually, I know how to increase viewership. Watch this. Jimmy's here as well. Jimmy's here as well. Now we watch. We're waiting on people right now. Yesterday I had like 10 people. And they all slowly went away. Everybody but us is in school right now. So I should do this at like 4 to 7. All of that is mine.
Octopus.
The company that set up this room doesn't exist anymore.
Surprising. Boy, what the hell? Bro.
Oh! Alright, we got one person. We got one lead. One person. We got one lead. Jimmy's in here. Who wants to say hi to Jimmy? We got one lad. Say hi to Jimmy.
Hello there.
We got one lad. Jimmy's in here. Who wants to say hi to Jimmy? Alex. One lad. That's Alex. It's just Alex.
Firewall?
Our
Hello
team.
there.
Our team.
Oh, okay.
It's Jimmy's in here. Who wants to say hi to Jimmy? Alex. One lad. That's Alex. It's just Alex.
Firewall?
Our
Hello
team. Our team.
Oh, okay.
It's Jimmy's in here. Who wants to say hi to Jimmy? Alex. One lad. That's Alex. It's just Alex.
Firewall?
Our
Hello
team.
there.
Y'all might as well get some good pictures. The stream's current bit rate is higher than the recommended bit rate. 2,500 kilobytes per second. The stream's current bit rate is higher than the recommended. Oh, we got two people. 2,500 kilobytes per second. They're slowly trickling in. I think we'll start at 12:30. Nah, we'll start as soon as we get a healthy amount of people. Oh, we got two people. 2,500 kilobytes. Yeah, I know. They're slowly trickling in. I think we'll start at 12:30. Nah, we'll start as soon as we get a healthy amount of people. Oh, we got two people. 2,500 kilobytes. Yeah, I know. They're slowly trickling in. I think we'll start at 12:30. That controls all the cameras and stuff in that room. Oh, we got two. This room. 2,500 kilobytes. Yeah, I know. They're slowly trickling in. I think we'll Jimmy, they have an entire server set up for something that voice meter could just do. Yeah, I know. Yeah. Jimmy, they have an entire server set up for something that voice meter could just do. Oh, also watch this. Yeah. Jimmy, they have an entire server set up for something that voice meter could just do. Oh, it's actually really good. Like this is a really good board. Yeah. Jimmy, around you, Jimmy. Oh, it's actually really good. This is a really good board. Yeah. Dude, they are. Oh, we got three people. They are trickling in. I knew it would work, Jimmy. Oh, it's actually really good.
How come you have a fan base and I don't? Where's my fan base?
Oh, we got three people. They are trickling in.
Oh, I'm more iconic.
Oh, it's actually really good.
They just don't realize. How come you have a fan base and I
Give me
don't?
that drink.
Where's my fan base?
Oh, we got three people. They are trickling in.
Far larger. I'm more iconic.
Oh, it's actually really good.
They just don't realize. How come you have a fan base
Ow.
and I
Give me
don't?
that drink.
Where's my fan base?
Oh, we got three people.
Four people. Far
larger.
I'm more iconic. They just don't realize. How come you have a fan base
Ow.
and I
Give me
don't?
that drink. What if all four of them are just me?
Oh, we got three people. Four people.
Far larger.
I'm more iconic.
Are you leaving this
No.
for me to use them?
What if all four of them are just
You're
me?
at nuclear camp.
Four people.
Far larger. when I'm at nuclear camp. Okay, I will. But you know what they say: you break it, you buy it. No, it's actually a really good microphone. I'm at nuclear camp. Okay, I will. But you know what they say: I'm just listening to the stream. No, it's actually a really good microphone. I can turn monitor. I can turn monitoring on though. Hold on.
Oh, it's your boy.
Oh wait, put it back on. Balls. Stream that to 4 people.
Boy.
Artificially inflating the view count. Stream that to 4 people. A lot of feedback on the audio. Oh, maybe I'm routing the audio back to itself. The view count. Stream that to 4 people. A lot of feedback on the audio. Okay, the audio should have gone away by now, but either way, feedback on audio. Wait, I don't have desktop audio on. Why is it listening? Like this?
Yeah.
Okay, tell me if the audio is still feedbacking. It's pretty cool. This room is wired terribly. Like, turn that light switch on and off.
Yeah, I know. I was in here.
Like, if you turn that light switch on, it'll be off. You go over and turn that one on, then it'll turn on. Go over there, turn that one, turn back on. It's so weird. Is there still feedback on the audio, guys?
I think it's good now.
Okay, good now. All right. We'll start once we get 7 people. That's a good enough. That's not about everybody just leaves. Jimmy, can you go get me that 2-liter of Dr. Pepper?
No.
Why not? Okay, y'all are gonna be babysit by Jimmy for now.
W. Hi. Bruh. Why is the audio so delayed? Okay. Okay, so we're gonna do some programming stuff. Go to WPI lib while Jonas is gone. WPI lib. Alright, what do we want to do? I just want to troll. Nope. I wasn't teaching them programming, Jonas. Don't really need it. Paper.
If you go stand next to the red thing, it turns on. Jimmy, when I give you the thing, everybody started leaving. No, I'm just kidding. All right, we got 7 people. We'll start at 12:30. Okay. Okay, if we have any like non-megabytes people in the chat, go ahead and speak now. You unplug me. Jimmy, currently it's doing the No, don't move that. I spent like 30 minutes perfectly aligning that to the board. Jimmy's ruining everything. All I do for this man, and he just huh? Hey, Jimmy, I don't have 8K60. Jimmy, this probably has an iGPU in it. I'm gonna be real with you, actually. Eight gigs RAM. Got I want to say hi to Jimmy. How would you do with my camera? I don't have access. The people who wired this room are dead. Oh wait, am I streaming this? Oh, I am. All right. Got. Is it 12:30 yet? No, we'll start at 12:30. One bad thing is that the school blocks streams. Like execute. Oh, my niece can't do this. Too far away from the mic for it to record this. No, it is in fact. There we go. Now I'm in this. Okay, never. Jimmy, do something Big Brother-ish. You will learn programming. No, Jimmy, I aligned it to the sun, Jimmy. This came from Clark. He doesn't get it. Why do I have PowerPoint open? Oh, PowerPoint open. No, I said don't open PowerPoint. I hate everything. We got a couple of people. We'll have more coming in, but so we'll go ahead and start. To make an account, look up on Google Onshape Education. So I'm eating right now. Sorry about that. So you get here, create ADU account, first name, last name, email. I wouldn't use your student email unless you have to, just because student emails go away after a little while, and it's a little bit of a pain to migrate stuff. Student, school level, grade school, if you're in an early college or university. You do this, and then it'll ask you for other stuff, address, blah, blah, blah. You can lie on most of it. It really doesn't matter. So once you're done making that account, you'll go to a page that looks like this. You won't have anything here. Create. So there's a folder you can make to, organize your documents. You can import parts from SolidWorks, and what it'll do for SolidWorks files is import them as a STL, pretty sure. And it can even import full Parasolid files and things like that. That allows you to have the actual model and rig it up and add mate connections, things like that. So it's very compatible with all our softwares. But we're gonna make a document right now. So you all can follow along if you'd like. I'll go over some quick keys. P will show and hide your planes that are in the middle, hitting the P key. If you select something, space is to deselect. You hit your middle mouse key, your scroll wheel, to move it around. If you press it, scrolling in and out moves. Right click will rotate. Left click will select and box select. So first, I want to talk about versions. So when you're creating parts and robots, you can create versions, which will allow you to say like, okay, here's this version, right? And then it'll be like, oh, okay, I did some edit, and then now I have this version. So if you have like your robot and you're like, oh, okay, I want to change the intake on it or something like that, you could create a version so that you can go between them and say, oh, okay, I want to have this version be an intake that is made of plexiglass and has hex shaft, or this intake is made of, compression wheels or something like that. So it's pretty useful to have different versions of things. Up here in the corner, there will be this plus key that has feature scripts. So this plus key will have different feature scripts, and they're really useful because there's certain feature scripts that allow you to import like mathematical functions to create helixes and things like that. Other features were like, for instance, you don't have to follow along with this. If I had like a cube, and I had like a hole here. So this hole right here is like, I want this to be like a screw hole maybe, and there's a feature script called internal thread, and all you do is just hit the inside, and it'll just create threads for you. I don't want to use this tool. Other one. Old thread creator. And it will just create threads for you. Ordinarily, you'd have to create a helix and then create your thread in like a triangle, and you'd have to measure that out and align it perfectly and all that to make sure that you're in the ISO standard of screws, and then you'd have to sweep it along there and then cut both ends or extrude both ends to make sure that it's properly aligned. This just does it for you all in one batch, so it's pretty useful to have. We'll go over all of 2D sketching right now. So you'll be right here, your 3D view. You'll have your top plane, isometric. So this right here is your different views. You've got isometric, which is your kind of standard view, and then different versions of that, trimetric. You've got different shading settings. You've got things you can make. Up here, if you want to export a part, you can always print it. If you have the enterprise version of Onshape, which is a paid version, or maybe you get a sponsorship for it, there'll be a whole render studio that allows you to render out parts, and they're actually extraordinarily high quality, very photorealistic. So that exports that image and it ignores the background, which is really nice. So over here, Sketch, big Sketch button up here, is Shift S. If you get to know your hotkeys, it's really useful. And then this little cube right here is for your adjusting of your view. We're going to go ahead and go to the top plane. So L is for line. Line is up here. Simple enough. Lines. Command Z or Control Z, depending on your Windows or Mac, for undoing and redoing, or undoing, and then redoing is Command Y. And it's Control on Mac or Windows. Square, there is a corner rectangle, which will be like that, and then you have a center point rectangle, do like that. Generally, you'll be using center point rectangles. Then an aligned rectangle, which is basically a 3-point arc, but for a rectangle. These are nice for intakes and things like that, where you need it to like come out. Circles, you've got your 3-point circles. I haven't ever had to use these in modeling, except for like prototyping, but you might find a use for them. You've got your standard 3-point circle. And then you've got an ellipse. Ellipses are good for making like slots for bolts to go through and things like that. So you've got your length of the ellipse and the height of the ellipse. And then 3-point arcs are perfect for like, if I've got, let's say, a corner rectangle right here. And I want to smooth that out. I can easily use a 3-point arc right here. So you click your 2 points, and then this is the radius. So I can make it aligned to those. You can see those little yellow cubes that show up means that you're perfectly aligned to whatever it's moused over. So that's easily made for capping that, making it smooth. You've got different arcs, tangent arcs, conant arcs. We won't go over these. This is for making your hex shafts. Describe polygon. You go in, you have less. Out, you have more. So I can make a hex shaft right here. And then your dimension tool is D. This is for setting the length of things. So I can say, oh, I've got a 1/2-inch hex shaft right there, and then it'll do it for me. Splines are for kind of free form. You can measure them out. Same with Bezier curves, I think is how you pronounce it. But splines and Bezier curves are mainly for free form stuff, where you just need like a curved shape on like an intake or something. You don't want to have to measure it out. You've got your text. Use, we'll go over that in a little bit. One thing that's really useful is, for this year, there was cubes, right? And those popped like super easily. So if you were to have a cube right here, and this were to be like, let's say your intake, and then like these corners are going to be touching the cube, you want to select your fillet here, which is Shift F, and smooth those out to, you know, however much you want. But you can smooth those out, and then now that won't pop a cube. That corner might, like if you cut this out on metal or plexiglass, that might pop a cube, but those corners wouldn't. And it saves you, if you're cutting your own parts out or you're having a company cut them out for you, then it really saves you a lot of time on having to file that down yourselves or having a freshman do that for you. So make sure to fillet any parts that are going to be touching game pieces, and even those that aren't, in case you have something hit or, you know, somebody like who's messing with it and might get injured. So it's always good to fillet down parts. You've got your trim, which is for like, let's say I've got, I don't quite remember, but if I've got like, I don't know, triangle, and then I want to like trim things out, it allows you to just cut it out, cut different parts out. So if I've got like a line that I don't like or something like that, you can trim it. I can extend things and split them. Offset's a really useful one. If I have like, let's say I want to just quickly model the chassis of a robot, and then it'll be like 32 inches. I'm making a 3.2 for scale. And then I want to say, okay, I want a 2-inch beam on every bit. I can offset this whole thing by, you know, oh, do that again. Offset the whole thing. So drag it all, select it all, enter, and then say like 0.2 inches, 2 inches for scale. And then now I've got like this part right here that represents the outside of my chassis. So that works really nicely. These are your constraints. So if I've got like, I've got a bunch of lines. So if you see that little yellow dotted line that goes on your line, that means it's either aligned to something or it's connected to something or whatnot. So there's a yellow dotted line right here. So this yellow dotted line is to represent that it's aligned perfectly to this point. And then like, let's say I move it over here. This yellow dotted line right here is to represent that it's aligned horizontally. And then this is for vertical. You can see the little yellow dotted line on the line. So, but you can always edit constraints. Like if I do this and I'm like, oh, I don't want this line to be horizontal to this. I want to be able to drag this line downward. You can always just select over, mouse over whatever you have, select that and then delete it. Delete your constraints. And now it's just vertical. That's the only constraint. But then I can mouse over this and say, oh, I don't want this vertical constraint anymore. And all of your constraints are up here. They'll either be in a drop down or be like this. Coinciding is probably the one you'll use the most. And it's like, oh, I want this here. Over there. If I'm designing, let's say, this is the 2D side view of a robot, let's say. You know, let's say my chassis is 32 inches by 2 inches. This is the chassis of my robot. I'm going to hide the planes. Let's say I've got a virtual 4-bar here that's like sticking out like that. Or actually a real 4-bar. This is a real 4-bar. So I can mouse over this and make sure that they're always horizontal to each other. And then I can I can click both of these lines and set them both to be parallel or equal. That's equal. I meant to do parallel. So undo that. And I can set these to parallel. Now, what I can do is get a point like that. Click this and this and make it coincident. Now, I've got a, I need to dimension this as 20, 30. Now I've got a prototype of a virtual 4-bar. Or a real 4-bar, sorry. We've been using virtual 4-bars a lot. So now I've got like a prototype of this. And if I want to like set this as like, oh, this is going to be 8 inches. Now I've got a 4-bar. You know? And then I could say like, oh, okay. How tall is this off of the ground? I can go over here to the measure tool and say, okay, this is 9 inches off the ground right there. So that would hit. Jimmy, how tall is high? How tall is the mid goal? Like a couple feet, right? 2 feet. Okay, 38 inches. So now what I can do is say, okay, I've got a 4-bar that's going to go all the way back here. We've got one that's going to go all the way back here. And then these are going to be parallel. This is going to be, I don't know, whatever it is now, 30. Now I've got a 4-bar that goes back, folds up all the way back here. And that extends a lot more because I said it'd be whatever. Mention that, say 15 inches, that works. This is now longer. So now this design, if I were to build it in real life, could easily, now it folds up all the way back here, but it could easily reach up, and let's see how tall off the ground this is. 39 inches. That's mid, right? Yeah, so that could hit mid, and you know, I might not have had the confidence that I could make a robot with a 4-bar that could hit mid. And if you do a little redesigning, you can actually find out that you're able to make a 4-bar robot that's able to hit high. So that's pretty nice. And that's kind of one of the useful things about doing a 2D CAD sketch early. So I'm going to start showing specifics on how to do things. So if I were to say I want to make a chassis of a robot. So we're going to go make us a bar. We're just going to make one bar of the robot. Say like, okay, it's going to be, what's our chassis dimension? 25 by 29. Okay, so we're going to do a 29 by 29 robot. Actually, we'll do a 30 by 30 robot. So 30 by 2. So we'll say, is that oversized? That was overbite. So we've got a 30 by 2 bar, and then we'll extrude that out. Say 2 inches. So I hit Shift E to extrude, and if I go into my sketch, it goes back into it. The extrude button is here, revolve is here. We'll go over revolve in a little bit. You've got your extrude. And I can always edit this sketch and say like, oh, I want this to be 1 or whatever, and it'll edit it. So I've got this bar right here. Then we'll put some holes in it. So we'll create a sketch, Shift S, create a sketch on here. If anybody is confused, you can ask questions in the chat if you're confused, or the Discord. Okay, Jimmy will tell me if there's any questions, so feel free to ask questions anytime you want. So we've got our circle here. We're gonna make a circle. Notice I made it a line to the middle of this here. I had the circle tool, which is C. I moused over this, and then I dragged it over here. And then once it's aligned to that little yellow thing, I just put it somewhere over here. So now I can dimension this out. Say I want this to be, half an inch away from that. Yeah, then we'll say, okay, I want a half an inch sized hole. And then I can extrude that, remove, and then select this blind. That'll mean it just cut whatever, and I can say through all, and that'll just cut through everything. Boom. So now I've got a circle right there. That cuts through this, and I can easily like thread this with thread creator. Now, if I want to cut them across the length of this bar, what I could do is just create like 32 individual screws. Or what I could do is go into the sketch and create a linear pattern. Linear patterns are probably one of the most useful tools in CAD, just period. Because I can set this to -1, want the holes to be -1 inch apart and go in the other direction. Then I can say, oh, I want 30 of these holes. And it won't render the middle hole, so it'll render the start and the end. And then you click anywhere off of the thing to select it. And then it'll update that part, because when I had this extrude, I have it selected as faces of sketch 2. So I can go over here and click sketch 2. And it'll select all the faces of sketch 2. Now I've got this beam with holes. What I can do is I can go to my assembly. So go to my assembly, and we have any questions? No questions. Go to my assembly and I can say, insert, and then select this bar right here. And now I can insert like 4 more of those. Imported 4 of those. I think I imported 1 too many. Yeah. So then I can like take each of these and rotate them 90 degrees. Andrea, you paying attention? Andrea. I'm going to steal her drink. Give me a second. Andrea fell asleep in my class. She's not very dedicated. Not very dedicated to the learning experience. Some people just aren't on that grind. Okay, set this at 90 degrees. You paying attention? You better know how to do this when we're done. You had a dream about it? And you know why we had a dream about it? Because I'm teaching it. So I can say like, oh, I want to move these around. Okay, so we'll have these two here. I can go to my top plane. Say like, okay, I want this part to be here. And I want this to be here. And then I'm going to rotate this one 90. And rotate this one by 90. And I'm not mating these or anything. I'm not connecting them mathematically. I'm just using this as like a reference. So this has taken me about like, 5 minutes to do. And if I wasn't teaching, it'd take me far less time than that. I could say like, oh, okay, connect these right here. And like, boom, there's my chassis. Or I could say like, oh, I'm going to use corner joints here so that the chassis is perfectly square. I could say like, okay, this is my chassis. And real quick, I want to go over to the App Store. Go over here to the App Store. And you've got all sorts of different stuff. You've got free data management. You've got free, simulate. Now, most of the stuff costs money. But you can look for free. There's all kinds of free stuff. This is free. You can import Google Sheets to reference off documents, all kinds of stuff. What we're going to look at right now is MKCAD. MKCAD library. This right here has every single Onshape, or every single FRC part, every battery, nut, screw, bolt, hex shaft, whatever, in Onshape. So I can go over here and say, oh, I want my swerve modules, and I want a Mark 4i swerve module with a Falcon as a steering motor, or a Neo as my steering motor, and a Falcon as my drive motor. Insert, and I can have like, oh, I want a Swerve X with 2 Falcon 500s, and insert that. It's like, oh, those will need like bearings. And look up. I can find the specific bearing that I need. I mean, it's got every bearing, every wheel, every piece of wire. Literally everything that you could find in your machine shop. FRC. You've got pulleys, pneumatics, motors, hubs, gussets. I mean, there's literally everything in here. Every single part. And it's all cloud-based. This isn't taking up any of the space on your, computer. It's even got the game elements here. So I can say like, oh, I want to test I have my robot. I want to test it in Onshape. I can click the cube and the cone, and I can click this, and I can say, oh, I've got my entire game piece. This is my scoring field. I can say, like, oh, could the robot, come up and grab from this? So I can test this all virtually, really easily. Not have to deal with any of the problems that a lack of, if you got a powerful computer, you won't have a problem with SolidWorks or Autodesk products, but when you have this, it just makes everything so much more convenient. But I can take these swerve modules and like say, oh, I want this to be over in the corner. Just move it around. I'm gonna align that right there. And this, I'm not doing this mathematically. I'm not mating anything. This is just quickly done. I'm not using any tools to do this. I'm just dragging everything around. And be like, okay, I'm gonna attack my swerve module there, and you say, oh, those holes I made, those don't align. This wouldn't work. And then I'd go and remodel that. So like go over here. Those holes don't work either. And like, oh, the wheel's too far off the ground for it to be legal, yada, yada, et cetera, et cetera. So this is just a quick way to like get rid of imperfections in your design. I'm going to be right back really quick. Just for a moment. Just hold on. I'll get back to it. Yeah, there's bugs in your skin. Bugs in your skin. Attention, or they're gonna eat. We can tell. So while I'm showing you this, I want somebody to name a piece of furniture in chat for me to model, and I'll show everybody my process for doing it. Don't name something complicated like a Chinese, trebuchet. Just name something like a desk or a furniture. Or a bed or something like that. So fielding is pretty useful to go over fielding and chamfering. So if I got like, let's say this was like on my intake, and I didn't want it to like stab anything or pop any cubes, I can chamfer it, which will just corner that out. So if I put this on a 5-axis CNC machine, it'll cut that out and it won't stab anything. And chamfer it. And if you're doing a public model for people to see, chamfering things just makes it look nicer. Like, tell me that doesn't look like just so much of a cooler bar. Look at that. That's amazing. Where are you going? No dedication in this one. Then we're going to fill it. Filleting is about the same thing, but instead of cutting it on a corner, it'll smooth it out. And again, it makes your parts look nicer. It just looks nicer. I don't know, you fill out your parts, you're not going to pop your cubes. It's that simple. There's probably more popped and broken game objects this year than all the other years combined. I mean, those cubes were, basically made of cling foil, We got a piece of furniture yet? Okay. So there's different niche tools like rib, shell, hole. This is just Hole Wizard from SolidWorks, basically, or Fusion. Every CAD basically has this thing. External threads, linear patterns. So if I had like, this, I can do like direction. I want it to go like that way, and then set it 5 inches apart. And then I want 4 of these. Boom. Now I've got that. So linear pattern. Rotational pattern, circular patterns are pretty nice. I'll show everybody an example of what those are good for. I'm gonna get rid of all that. So if we got like we'll unhide our plans. Hit P. We'll go to isometric view, and then we will. I'm gonna align ourselves to the top plane. Is everybody hearing me all right? Just making sure. Nobody's name. No one's naming furniture. Nobody's naming any furniture. You gotta name furniture. We got 12 people in here. One of you can name a piece of furniture, right? All right. So we're gonna make us a rectangle. Actually, we're gonna make a circle. Let's say this is like our gear. We had like a 5-inch gear. We're gonna put a motor in here. So we're gonna make an inscribed polygon to make a hex shaft. That a 6. Because hex shafts have 6, We'll make a line middle of this to the middle of this, and then make that horizontal so that our hex shaft is like that. We'll make it a 1-inch hex shaft. And then let's say I've got here, and then my motor, I need like screws or something like that. What I can do is make circles here. I can say like, okay, I want a circle right here. And I want to like half-inch circle right here. And say, oh, I want a circular pattern. And I can select this, and it'll do it for me. And there's a little like box right here. I can move this around anywhere I want, and it'll move the circular pattern. And and then I want like, I don't know, 7 of these holes. You can set it to be any number of holes. I want 6 holes. And now it'll make these holes, and then I can, when I'm cutting out whatever part this is, I can easily just extrude this out like an inch. Actually, I'll do like a 1/4 inch. That was a good time to mention. You can, when extruding parts, or when typing anything, really, so this extrusion, I can say like a 1/4 inch part. But I can also say like, oh, square root of, 16, right? That's 4. And then I can say like, oh, square root of 16. 1 over square root of 16. That's a 4th. Or I can say like, oh, I want, 1 divided by 1, over. You can do any mathematical operator you please in here. So if somebody's like, if your math teacher decides to have you model something, you can impress them with that. And so this would be like, I don't know, my plate that I'd cut out. I'd stick a hex shaft through there or whatever. We'll go to our public document real quick. Like this is our public byte document. This is this year's robot. One thing that's nice, now this larger assembly, it takes a while to load. Like it'll take a minute, but even on a good computer, an assembly like this in a non-cloud-based software could take forever to load. And honestly, we've been using SolidWorks for like 7 years. Every time we try to open an assembly on an updated version or an assembly that we added some, part to, half the time the assembly would crash and we have to go back and fix some part. Onshape has never had this problem. We have never had a problem or a bug with Onshape, except for minor things like it not being able to properly math out, a sketch with 40 different definitions that are unnecessary. So this will take a little bit of time to load, but if you've got a really bad computer, this will load a lot faster than it would on SolidWorks. And in my experience, even on my pretty good computer, parts load a heck of a lot faster than they do on Onshape. I've had very few problems with loading times on it compared to SolidWorks, so that's pretty nice. And I can even move around this part. This computer is from let me check the date on this computer. I've been modeling on this computer right here for the classes, and this computer is from like the, I think the 1900s. No, not 1900s, 1990s, early 2000s. This is a very old computer. And, it's running fairly well. I've been able to model all the parts so far. It might not load this large assembly just because of RAM, but we'll see. I'm also streaming and recording, so. Table. Alex says table. We're going to model a table. Okay, we're going to let that rest. If you have a computer that wasn't made in, 1990, you should be able to load the large assemblies. So we've got, I'm going to be right back for just a brief moment. Okay, I'm back. So now that we're back, stream running. All right, so let's see. Somebody said table, I think. He said table. All right, we're gonna show the process of modeling just a table. Select all these, get rid of that. Okay, just hit delete. Yeah. Select sketch 1. Delete. I could just select over here and hit delete. We're gonna look up a table. If I had more people, I would let you all pick which table, but I'm going to pick which table. I like that table. I'm not going to model that though. I think it's a little too complex for this early in the class. There we go. We're going to model this table, including all of the little bits and features. I think this is a pretty good practice run. You know, lots of details to chamfer out now. That's something I'd do in Blender. I would never do that in Onshape. Also, I was being paid a hefty sum of money. We're going to go back here and look at we're going to do this one right here. This wonderful little table right here. It's got a circle. And if I zoom in, it seems to go up a little bit. We can actually replicate that. So what we're going to do is so create a sketch on the top plane. We'll align ourselves to the top plane. I'm going to say this circle is about I'm going to say it's about a 2 foot. Yeah, we could say 2 feet. And then I don't know how thick that is. I don't want to buy anything. Sorry. Yeah, it's like a inch thick. Make it easy. And then this is pretty smooth, you know, not too smooth. So we can say, you know, a little fillet right there. Bottom smoothed out as well. So I hit Shift F and then fillet both of these just a little bit. You know, I could say like, oh, I want that to be. I'm gonna do 1 inch fillet. No, that won't work. 1/2 inch fillet. Yeah. Now I've got 2 fillets going on here. So it's a little bit smoother of a pancake. I can right click this part and set the appearance as well. Edit appearance, and I can say I want this to be gray. There we go. I'm gonna go ahead and hide my planes. How big is this? I'm gonna say that's 4 inches. So that little yellow cube right there, little square, you can zoom in and see it. So that, and then it's selecting this center point. That means that I'm aligned to the center point. So that's a square. Hit C for circle. Expand that out a bit. 4 inches. That go up. I'm gonna say this table is 3.5 feet tall. 3 feet. 3.5 feet. There we go. And then I can fill it right here. Like 1 inch. 2 inches. And boom. Now I've got that. And then I can also select the shaded without edges. Now all of those little lines are hidden. It looks a lot nicer. Yeah, so that's all one part. And then I can say, okay, this goes up, and then this table, we'll say that's like 1.5 feet by 1.5 feet. So I can create a sketch on top of this. And say, now once I create a sketch, I should have mentioned this a lot earlier, but once you create a sketch, I can say, so I haven't clicked anything. All I did was create a rectangle, hit the middle, then expand out. And say 1.5. Now I immediately just started typing, and it'll dimension that. And then I can just hit 1.5. So it'll immediately automatically dimension that stuff for you if you were to start typing dimensions once you create a rectangle. So I can say 1.5 feet, 1.5 feet. Now it actually looks to be significantly bigger than that. So we'll say that's like 3 feet. There we go. And then I can say, okay, that's probably like 1.5 inches tall. I'm just kind of eyeballing it, you know. The best way to get practice for modeling is to keep doing. And I can actually make this a new part, so I can have the top and the bottom of the table be a different part. But what I can also do is have it be the same part, right-click this feature, and then say add appearance to feature, and make this like a wood color. And then boom, now I've got this table kind of done. Need to fill it out, all the edges of the table. Maybe I can get away with full rounding it. No, I can't full round it. So I can say like, okay, fill out this top face here, bottom face here, and then make it like less than that. I created a little kind of cool little design. And then I kind of added the appearance to this feature and say I want this to be wood color. Then I can select this face right here, bottom, these faces that are created by the fillet. Tomorrow I'll have a little thing that displays what keys I'm pressing while I'm pressing them, just to add appearance to these 5 faces and make this like a gray. And then I can go over here to my appearance tab. And I want this to be this part to be that same dark gray. And now I've created a nice looking table that I could easily right click here and export as an STL. And I could easily 3D print this out and have me a nice little table. I'll share this part. Could set this public document, and then can share the link here. Go ahead and drop that down in chat if anyone wants to have that table. Now anybody can access that document whenever they want. And they could easily go down and export that. We have any people looking at this document? We'll see. We've got Jay. That's just me. Who is that? Pretty sure it's just Jonas. I think that's just me. Yeah, I think that would just be me. Yeah, it's just me. Anyway, but I got this document. You know, you can go and download this if you'd like. 3D print it. And then I encourage you to make your own furniture and, you know, just get practice on modeling different things. Hold on, I want to listen to my voice real quick. Okay, I like my voice. Sounds nice. Mute that. Okay, let me just see what we should go over next. Give me a brief moment. You'll have to give me like 1 or 2 minutes. Alright, I'm back. I'm gonna try and load our robot again. Tiny bit. Got about 14 people here. My Dr. Pepper is empty. If anybody has any questions or features that they're a bit curious about, now is a really good time to ask. I'm fixing to go over mate connectors and things like that. I wanted to go over that next week, but I think I've been able to hit most of the points I wanted to hit so far today. So we'll go ahead and go over that a little bit. But I'd much rather go over any questions that people currently have and anything that we want to learn about or try and do or whatever. Any small thing, doesn't matter how small. I really don't care. It's not a bother to me. Any tiny, whatever thingamabobbers you want to learn. Any little features or parts or things that stand out to you, go ahead and just point them out. Okay. Now, if you've got, a laptop that was made in the last 10 years, you should be able to load large assemblies like that. And, this is pretty old. There is like a cloud-based software allows you to load much more complex parts on a much weaker computer, but there is a line to draw there. So if you've got like, a Windows XP era computer, you might have to spend a while loading a large assembly. But that compares to, on SolidWorks, something like that, where it just would not load at all if you don't have, the required specs. Or on Inventor, where it would crash when you try and breathe on the document. Alright, so we'll go over mating a little bit. We'll keep the table. We'll make a new parts video. Go ahead and clear this assembly. I've got all of these parts that... mating is the act of joining parts together. It's the mate connectors and things like that is for... that right there, mate connectors. Those are for fastening parts to go. So there's different things like helixes for screws. There's a lot of simple stuff, planes, mate connectors, whatever. We're going to do another table. This time we're going to make each of the parts individually, and then we're going to join them together. So we'll make a couple more studios. And we'll start this habit of when I make a part. So I'll make a sketch, and this will be our... say that's a table. All right, how big is our table? Let's make the table really small, 4 inches by 4 inches. Now what we're going to do is select all this right here, and we're going to make this construction geometry. Boom. So this is construction geometry. Now when I extrude it, it doesn't count, basically. It just doesn't exist when I try to edit the part. This is purely here for reference. Now what we're going to do is create a rectangle right here. Now this is a really important lesson, what I'm doing right now. So if you've got anyone not tuned in, make sure to get them to tune in. This will be pretty significant, because I'm going to hit a lot of important things on this part of the video. There we go. Okay, so this will be the 4 legs of our table. I'm going to extrude these. They're going to be so just tall, pretty tall table. Okay, so now I've got each of my individual parts. Now we're gonna make an end table. That'll be the type of table we make. Now I did this yesterday, but yesterday was kind of just a test run day to make everything work, make sure everything works. So we'll go over. I don't want to be in shopping. I want to be in images. I found a really good table. This is our table yesterday. So I can easily download this image. I already have the image, so I can replace it. And then what I can do, I go into this front plane sketch right here. Hit the front plane, and then I can import an image right here as a reference, which is really nice. But what I'll have to first do is import this image as... So I'll import that image, and then I can use that image, and I hit that, and then I can drag it outward. Actually, what I want to do is... I'll redo that. I don't want it defined to anything, so I'll just tab the image, and I'll put it over here. And then boom, now I've got my reference image, and even if I complete this sketch, it'll still be visible. It'll only go away if I hide this sketch right here. So this sketch is basically just that image. That's what it is. And I can even go in here and say like this is, put some text up here. Say like, oh, I want this to be... I'm gonna move this around over here. Yeah, okay, that's my table. So now I've got my end table, and I kind of want to say, okay, we've got that top bit kind of cube into there. This little thing kind of goes into it. So what we'll do is we'll create a plane. What we're actually going to do is this bottom bit here first. So we'll create a plane here, and we'll use the top plane as our reference, and we'll offset that by like an inch. So we're making, just to be clear, we're making this little section right here. So you've got your table. We're making that bottom bit. Got our table. We're making this part right here. Right, we're making this part of the table. This right here. This is what we're making. This part right here. If you're wondering how I'm doing the drawing, I have a tablet, or like a Smart. That's the name of the company that makes them. Smart tablet, whatever. From the college that I'm at right now. Using their stuff. So I'm gonna make a square right here. I'm just gonna put it right there. Notice I have it aligned to the center. And what we're gonna do is I'm gonna make a line. So I'm gonna hit U. This is the U's. This allows me to basically take any geometry that I want and just grab it. So if I have like, you know, this A over here, I can put that down onto that point, right? I have this, you know, corner of the T. It puts it down onto this plane. So if anybody has any questions about that, ask them. But I click any geometry and it just basically, like if I were to, you know, have whatever, it just puts it onto that plane that I'm sketching on right now. It'll just use that as reference. So now we have this. I'm gonna say this is like, I'm gonna make a line. Goes this way, like, I don't know, an inch. No, not an inch. Okay, what we'll actually do is make two lines that go this way by like 0.2, and then this way by 0.2. What I could do instead, now this isn't the same measurement, but if I want to do one line, I could say like, oh, this is going to be, what's the Pythagorean theorem? The square root. I'm going to dimension this as like, I don't know, square root of 2 plus, I haven't taken math this semester, so I'm a little rusty. Calculus 1 was last semester. I don't know what that is. I don't know what I just made that. Divided by 2. I don't know. I have no idea what I'm doing. Okay, that's divide that by 4. I don't know. This is wrong. I'm trying to calculate it, but it's not doing it right. Okay, we'll just make this 0.2. I give up. Okay, and then we can hit for dimension. This is an important part. Pay attention. If I hit this line and this, I've hit 2 lines. I can make a degree. I can say this is 45 degrees. Now it's perfectly facing the center. And now what I can do is hit this point right here, and this point right here, and hit I, and it'll make it coincide. So then I can hit Shift E and extrude. Get rid of all that. I just want to extrude this face right here. And then I can hide this part right here. Which part is that? I'm going to hide that part. Extrude that. And then hide that part. Extrude that. So now I've got all the corner bits selected, right? Double check that. So I've got all the corner bits selected, everything I want. And I can make it symmetric. 0.2. So making it symmetric will, so this is the yellow bit is the plane, right? Yellow bit's the plane, so it's extruding this way. But if I make it symmetric, it'll do half as much both ways. So I'll make it extrude through. And then I can show all this. And boom. And then what I can do is, now that I have that, right? So that's that middle bit right there. You know, it doesn't quite intersect the edge. I can do the same thing with the top plane. So what I do is create a sketch and then use this geometry right here. Then I could just extrude it downward. Do that arrow and make it go the other way, and then say like, boom. And then now I've got my table. Right? And then I can go on top of this. Make another like, let's say 5.2. I guess that's probably a good measurement. Screwed that up by like, you know, tiny bit. And boom. Now I've got kind of the same kind of shape going on. These are obviously a lot thicker, you know, it's a little different, but it's good practice. It's good practice to do things like this. Now you've noticed I've made these all individual different parts. We'll get to that in a little bit. Then I'll just do the front door real quick. I'll go to the front plane. Okay, I'm on the front plane. Sketch out that drawer. We'll align to the middle of that. And then the middle of this line. We'll take the center of that and go out just a bit. 2.25 and 1. And we'll remove that bit there. Then we'll take the inside of this right here. Right, and we'll offset it. Put a sketch on there. Then up here is offset. Offset that by like 0.05. Then extrude the drawer back out. That would be like 1.05. Stick out the tiniest bit. Now you can see the drawer kind of goes like out a bit, and then it goes in, and then it goes like flat, and then you have the doorknob, right? So what I can do is say, create a sketch, and then offset that. Have it go the other way. I don't know, 0.5. There we go. I will say 0.1. And then extrude that in. Hit remove. Nope, not surface. Hit remove, and then hit 0.1. Now in CAD, there's really no wrong answer. As long as you get it done, you know, there's 1,000 ways to do everything. I'm going to go ahead and go back to because I think it looks a bit odd, so I'm going to go back to this sketch right here. And I'm going to, actually not that sketch, it is this sketch right here. And I'm going to make this offset like half as much. Second series is 0 points. Divide that by 2. And now it just makes a tiny bit more sense. And then I'm going to actually make that, what I'll do is make that fourth as much. Hey, hello. Okay, the lights just came on for some reason. I don't know. And then we'll chamfer that. 0.1. Okay. That goes in a bit. Now, and then that's not the only way to do it. What I could also do, now, like I said, there's 1,000 ways to do different things. I could also just straight up like extrude this, remove, say 0.2, and then draft, which is used for cast molding, but you can use it for, you know, whatever you want. You can use CAD for whatever. You don't have to, you know, you can be a rebel. You can go outside the constraints. So I can just draft this by 30 degrees and say, okay, now it makes basically the same part. So this doorknob, right, it's kind of a round thing. Now, of course, I could do like a cylinder and then fill it in, but we're not going to do that. What we're going to do instead is say, okay, this drawer knob, right, can't really view the side of it, you know, as much as I want to. Jimmy doing? What's Jimmy doing? Jimmy's gonna get smacked. This is what Jimmy's doing. So we got this table, right? So from the side view, this is what the doorknob kind of looks like. So from the front, you know, you're looking at your drawer, you've got your knob. From the side, what it probably looks like is this. Right, and then the person, you know, comes over here. I'm no artist, I'm an engineer. Comes up and grabs this, right? Okay, so that's what the drawer knob looks for the side. What we're going to do is say, okay, I've got this. I'm just going to model this section right here. And then I'm going to revolve it around this line right here, and it'll just extrude it out. Now, if you don't understand, just follow along, bear with me. You'll get it in a moment. You'll get it in a minute if you don't understand yet. So we're going to create a plane here. We're going to create a mid plane. Right, so I'm going to select this line right here, and then this line right here. Okay, actually no, what we're going to do is not select the lines. We're going to select the points right here, and it'll create a plane right between that. So now I've got a plane right here. We're going to create a sketch on this plane. We're going to use this face right here to make sure we're having it. And then we're going to go to the top. And I'm going to do, say this doorknob, this drawer knob is going to come out like 1/2 inch. Yeah, 1/2 inch. And I can create a spline here, just and like freehand it, right? Because I said, you know, the side view and the top view is going to look the same. You know, it's like, it's just going to look like that. So I just basically remodel that, and I can even use my tablet to push that out. I can say like, oh, is that going to work? Right, that's what half of it kind of looks like. Jimmy's over there snickering. I can just freehand that. And align myself to the center of that. And then instead of making that half, now I can just make it coincident. Hit that point, say I. And then I can hit this button up here, revolve. That's my face that I'm using. Is right here. And then the revolve axis is going to be that middle point right there. And then boom, now I've got a drawer knob. I'm going to make that a new part. So that looks a bit big. Now we're going to show you a new part. A new thing called transform. This is just to like quick and dirty, edit some part. We're going to scale this in place. The mate connector that we're going to use, so this is, we'll enter the mate connectors right here. So if I mouse over this center, this little line on the outside right here, then it'll put the mate connector right there. So what we'll do is, if I were to put the mate connector right there, what it's doing is when I hit scale, let's say 0.5, make it a half as big. Shoot. I want to scale this part right here by a half. What it's doing is, because I selected this right here, it's basically it's shrinking all the geometry this way. And if I were to say like, oh, I want to put the mate connector, you know, over on this side, this will be my mate connector. It would shrink everything that way. So wherever you put your mate connector is where it's going to like push all the geometry towards, basically. So that's how that works. And I can do different things. I can say like translate by XYZ, which is just moving it. I don't know if you've taken high school math yet. Maybe you're middle schooler, who knows. But you could translate it, you know, rotate it. Which, I mean, that doesn't, rotating a cylinder doesn't really anything. But we're just going to scale that by half. And then boom, now I've got this part. Now, what I could do is merge all of this together. I can group this all together. I can go to a Boolean and union all of these parts together. All of this, I can just union it together. Now this is all one part. It'd be super easy to 3D print. And I can even go in here and like add appearances to faces and change the look of it if I wanted to make this a public document. You know, I can, that's a different gray. I don't know if you can tell. Make it just an orange, you know, whatever. I can do that. But what I can also do instead is go to my assembly, and this is, I'm just going to go ahead and demonstrate mating. So I can import my parts in my part studio. I've got all these parts, and I'm like, okay, cool. Now I want to move this around. Ah, it's not connected. Uh-oh, what are we going to do? So now we do mates. So this would be kind of hard to mate, just because everything, I didn't really math anything out. I just kind of did whatever. So I'm gonna disassemble this table. I'm gonna rip it apart. First we'll do this bit. Oh, I did something wrong. We'll make a mate connector. And we'll put it right here. And then we'll realign it. Or move it, not realign. And I'll say like, okay, I want it 2 inches that way. 2 inches that way. So now it goes to the corner. So then I can fasten this there, that mate connector, and then this middle part. You can see when I mouse over something, there's automatically like mate connectors generated, but if I want to make a new mate connector like in the corner here, you know, if I want to make it in like this spot right here, like there's a mate connector here and here, but if I want it right here, that's when I have to make my own. So I can fasten that, and now these two are connected. I'm not going to do the whole table, but I can also just like fasten this and this. I select it. Sometimes you have to align yourself to the proper point. Then I can drag this, that, and fasten, you know. What I can do is fasten this right here. Yeah. Oh, what she did. Got a marker. Did you mark on that? Jimmy's messing up stuff. Jimmy's causing trouble. That's all Jimmy ever does is cause trouble for us. Unless we'd probably be better off with Dustin. I turned off Jimmy. I used the remote control, so I'll make that -3. So I can set that. I don't know, -2.5. Oh, what did I do? I did something wrong. I messed it up. -2.5. What's this? -2 plus 1. Whoa, math. That's so cool. So then that's all like that. And this is put together. I don't need to do the rest of this. You'll figure it out just from these. Okay, so that's these make connectors. I'm gonna go ahead and use one of my old files to demonstrate. Go back to streaming. See if that. Yep. Ah, there we are. Okay. So this is a little funky little dude that I made in one of my classes when I should have been doing my work. I made an A in that class, so it doesn't matter though. Well, he's not put together, is he? He put together. So he's not put together. He's broken apart. Yeah, he's not put together. But you know who is put together? I think this guy's put together. He's not put together. Okay, I gotta find one that's put together. There we go. I'm not gonna turn the webcam on, Jimmy. Actually, we'll do it. Oh, you mean like just have this in the bottom right? Good guy. Look at me. I'm so beautiful. I need to shave. I'm looking. I tried to do that, but this computer right here does not allow that. It just doesn't. OBS is not allowed to record windows for the display window. It just doesn't. If you set window and then select anything that's not OBS, it just shows a screenshot for whatever reason. Like, it's really odd. Ever. Okay. So this guy's rigged up. This guy can move and groove. That's what he's made for, is to move and groove. That's his sole purpose in life. I'm gonna just move him around a little bit real quick. This guy can in fact schmoove. He does not pass butter. He moves and grooves. So now this is the amount of parts in it. That's a lot of parts. But none of them are entirely complex. All they are is just cylinders, a circle, some more cylinders, a big cylinder, this trapezoid here. There's really not that many parts into it. They're just a bunch of cylinders that I put in different spots. This was a couple years ago is when I made this. This was probably the most difficult part to do. Right here. And all it was just, I extrude this thing out. Like, I just make this shape right here. So I just made like that shape. Then I just extruded it outward, and it did that. And then I made a sketch on the side that extrudes it outward. So, this guy's all rigged up with. Now he's not like rigged up like movie thing, but I've got a lot of facets here, and so this is the example where different mates are kind of useful. Now this obviously would apply to like. If I had something like this, if I had something like that, then I would need, ball and socket mates and all kinds of different stuff to do something like this, especially if it actually was a ball and socket mate. I'd need a ball and socket mate right here to rotate or different things. So on some of these areas, I've got like a ball mate right here that allows it to, move that way. I've got, you know, rotary mates for the shoulders. I think this is mostly just ball mates. But yeah, I've got a lot of different mates here, and this is kind of one of the applications that you can use for it. This is just made for fun, obviously, but we can go and we can make us a mock robot arm. Just check on everybody real quick. We've got 14 people playing around. 4 minutes. People are only watching. This stream's been going on for an hour, 2 hours. Has it really been going on 2 hours? Is that right? Didn't I start at 12:30? Started at 12. That's odd. Well, why does it say 1 hour and 30 out of 2 and 30? Why is there a maximum here? Oh, that's odd. Anyway, we'll make us a mock robot arm. Robot arm. We'll just make something. We'll just make a simplified version of whatever we can find on the internet. Now we're not gonna model this, you know, precisely, but we'll get sort of close. So that's like, I don't know, a hexagon, and then it kind of comes out. So we'll just do that. I'm not going to measure anything out. I'm just going to show the capabilities of the different parts. Then I'll make this go out like here and say this is just to show all the different features. And then I'll chamfer. Can I chamfer? No, I can just fill it. So I'll just fill it right here. And then that up a bit. Hit sketch 1, extrude it up a little bit. People. I don't have anything else to throw. Let me go get me something to throw. Okay, we're back. Anyway. And then I can go into my sketch. I'm not going to offset this. Right here. That's just a circle. Actually, you know what? We're just going to offset that whole thing the other way a little bit. I'm just going to do this real quickly. Okay, it goes up a bit. And then we'll create like a little bar right here. So we use the right plane. We'll use this point here to create a circle. Extrude it symmetrically. Now what we're going to do is okay, we'll create a new part here. Use that circle right there. What we're going to do is we're going to make a new part. Now it's going to look really weird first. This is going to be a mock, a megabyte arm as well, kind of. It'll have the same sort of principles. This is going to look pretty weird. I'm going to make a new part. Metric. And then we'll make that much smaller. Version much smaller. And we'll extrude this up to be a lot taller. And then what we'll do is we'll transform this. Actually, we're not going to transform it. We're just going to have 2 of these. We'll transform it just to duplicate it. Actually, we're not going to duplicate it. Never mind. I lied. I'm lying. I'm a big liar. We're just going to circle in here. Make it like that. We'll measure that just to make sure it's right. Remove that, and then what we'll do is we'll make another part just on the front plane that has a 0.5 and we'll have the center line right there. And we'll mirror that across. There is a mirror tool. That I should have mentioned that like hours ago. The mirror tool is quite useful. We'll extrude this by 0.2. Then what we'll do is we'll in all the same part, we'll unhide the sketch, select the circle, extrude that. A additive part. Okay, and then we can go to our assembly. Make a habit of naming parts as you go. Like I can name this arm, and I can name that table. Make a habit of doing that. You do not want to have a robot with 300 plus parts and all of them be named assembly 1, 2, 3, 400, 750. You know, you do not want that. Trust me on this one. So we're going to import that arm, and then we're going to hit this drop down and import another one of part 2 and part 3. And then we'll start mating this up. So we'll do a revolute mate, and we'll hit this right here, this circle right here, and then this right here. Have it go the other way. Rotate it a bit. And then we'll hit that. If I mouse over this and then hit shift, it'll allow me to just select mate connectors from this. I can align myself properly. No, I don't want to hit. Mouse over this, hit shift, and then I can mouse over here. And you know what, I'll just hide this part. That. Unhide that part. That. Rotate it. Make it go the other way. And then we'll revolute this right here. This right here. And select that one properly. Okay, we'll just select the middle right there. We'll undo that actually. We'll fix this part so it doesn't move. This will be our base. And then we'll add a revolute mate in the middle of this. We'll select this one. So middle of this. And then the middle of this. Over. This right here is for my tablet. This isn't from and middle of that, make it go the other way. And then boom. Now I've got kind of a mock joint that I can rotate. Now it doesn't have inverse kinematics unless you add definitions. But now I can say, okay, if this were like a robot arm, for instance, I wish I could open the Megabot arm because the Megabot arm is completely rigged up, so I can move every part of our robot virtually. And if I were to say, okay, if I'm going to scale, can I transform this? No, I can't. But if I had like, okay, let's just say hypothetically, that this was, oh, I hit the wrong key. I did something wrong. Tablet's messing up a bit. Let's say this is our robot, and I've got like the chart, the thing right here, and this is the arm that I was using. I could be like, oh, this would totally be able to like store a cube, and then, you know, I could easily like move this up and then move this out and place a cube. Oh wow, look at it, it's so cool. Or I could say, if this was the charge station, it'd be like, oh, this is our robot, and I could easily like actually import. Now this is, you know, 4 inches tall, so 16 inches tall. This is a like small robot. I didn't model it to be big, but if I actually had the proper sized robot, what I could do is just go over here, say game elements, looking for this it? That's the substation. Want that? Do they have the? It's gonna take a little bit to insert. All of the game pieces are available online. So this is the substation. I could easily like move this over, and if this robot wasn't, you know, 16 inches tall, I could easily like say, oh, it's gonna, you know, reach over and grab that, and I could test and see virtually if it was gonna work. Well, maybe I can pull up a file that isn't as complex. I know that one of our oops. This is some of our robot concepts. This is going to be our old. This is one of the many designs that we had come up with for the robot. This could have been our robot this year. There was a chance that this would have been what it was. And I, you know, rigged this up and said, okay, this is going to be all mounted to an elevator mechanism. It was an extraordinarily complex robot looking back on it, and it wasn't viable at all. But what was going to happen is these were going to flip up, and this is going to flip up, and then these would go out and push it all back, and then yada yada, et cetera, et cetera. It was very complicated unnecessarily. And so this was this is not my proudest moment. But when it's in assembly, I can easily like move these flaps or move this joint or whatever. And test, you know, how it would work. I think all of this is fixed as to keep it preserved. But another example, I think I have one of our full old robot designs. Not sure where it is. We have our field elements in here. There it is. Here's one of our old robot designs. So this is the prototype for our current robot. This was like the early prototype. We didn't build this. This was in CAD. This is the first time I've ever shown anybody our failed designs. So you dozen people that are listening in get to see them. I don't think even Andrea. Robot before. So, okay, so the 1990s computer can't load it, but what I could do is I can drag, when I've got my robot, yeah, I can grab these and just drag it wherever I want. Oh no, it loaded, never mind, okay. Okay, so it'll load even on the 1990s computer, how about that? Hit space to deselect. Sometimes it just takes a little while. So I can grab this. And a lot of this is the parts, and so like that PID or PDH and the breakers and things like that, that has a lot of vertices. That's probably the majority of what's causing the slowness. But I can grab this. I should be able to, at least. Grab it and rotate it. And rotate it. And I could say, okay, this could go place on mid or high or whatever, whilst being able to fold up into the chassis. So that's and so I can fold this out and have it go all the way up there and test it. And I tested this extensively. But I could say, oh, this will. Yeah, it'll be a bit. This computer is not the fastest, but if I were to put this model in SolidWorks, it would just not open, or it would crash. So that's, there's something to be said there. Usually the people who really like working with SolidWorks as a team are the people who have like 2080 Ti's in their computer and they have 32 gigabytes of RAM. So, if you've got, like, we run our Onshape on, like, we have MacBook Airs, the M1 MacBook Airs, the ones that keep blowing up on the screens, the real bad ones that are 8 gigabytes. And we also have a set of Intel iGPU laptops that are about like 10 years old, and they run Onshape just fine with virtually no lag. So anyway, we're going to move along. I'm going to take questions now. If anybody has anything they want to go over or mention, I'm going to sit here for a little bit and let people ask questions in the Discord or in the YouTube chat. If there's nothing else, I'm going to let everybody go, and we'll go over a lot more advanced stuff next time. So I'm going to sit here for about 10 minutes, 20 minutes, and then everybody can ask their questions or want me to go over something or mention something. If not, we'll just close it off here. This will be recorded, though, so if you're looking at it right now at the end, you can always send it to somebody you know or have them watch it, because most people are in school still. I think like 90% of the people that plan on attending are still in school until like June 10th. So send this to them so that they're able to watch it and learn a little bit. I don't know who all is paying attention currently, but I am taking questions right now if anybody has them. Okay, we don't have any questions, it seems like, so I'm gonna go ahead and let everybody go. Encourage other people to watch the stream recording, so hope everyone has a good day. See you.